Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE higher level exam practice with the Batty Boffin again. Today we're going to be going driving in our car with Bathilda the Batty cat, and today she is going driving up to some traffic lights. Now, these traffic lights might be at stop or they might be at go. We're going to kind of ignore that kind of orangey weird colour in the middle. The probability when she gets to the first traffic lights that she has to stop is 0.4. Okay, probability when she gets the first ones is 0.4. If she has to stop at the first ones, then the probability that she has to stop at the second one is 0.6. Okay, so probability that she stops at the first one is 0.4, and if she stops at the first, then the probability that she stops at the second is 0.6. This will make her late. So for the first part, part A, what is the probability that Bathilda is late? So pause the video and do that bit now. Right, let's go through that together. I'm going to write this out formally. You don't have to do this bit, but just to show where it comes from. The probability that she has to stop the first time and she has to stop the second time. Hopefully you know that an and is a times on here. Stopping the first time is a 0.4, stopping the second time is a 0.6, which gives us a grand total of 0.24. 0.24, the probability that she is late. Okay, that's part A. Now for part B, you're told that the probability that she doesn't have to stop at all, she just goes straight through both of them, so they're both on green, the probability of that is 0.36. Okay, that's the probability of no stops. So with that, could you please draw out a probability tree diagram to show this with all the probabilities on it? So that's part B, off you go with that. Right, let's draw that out. I'm going to do one of those speedy up things because I think it looks quite funny. Here we go. Right, that's the information we've got so far. We're told that a stop at the first light is 0.4, which means that a go must be 0.6. We're told that if you stopped the first time, then the probability of stopping the next time is 0.6. So that has to be a 0.6, which means that that's the 0.4. Please note, we're not told that that one's 0.6. We're not told about that one. Okay, this stop was the stop on the second light, provided it had been a stop on the first light, so it's only that one. However, we can work out these down here from knowing that go is 0.36. So if go followed by go is 0.36, then this must be a 0.6, which means that that one must be a 0.4. Okay, so I hope you're okay with those. That was part B. For part C, I'd like to know please the probability that Bathilda the Batty cat gets stopped at exactly one traffic light. So that's part C. Right, getting stopped at exactly one traffic light means that exactly one, not none and not two. It's not the same as at least one. Please be aware of the difference between those. Getting stopped at exactly one traffic light is this route through the probability tree diagram or this route. So for here we need to do 0.4 times 0.4, which is 0.16. And for this one, a 0.6 times a 0.4, that's a 0.6 times a 0.4, which is a 0.24. Okay? And we want either this route or this route. And or is an add, so I'm going to do this, I think, in a different colour. Let's go for here. So we need the 0.16 or, which is an add, the 0.24, which gives the grand total of 24, 30, 40, 0.4. 0.4 for the total probability that you'll get stopped exactly once. Right, hope you had a bit of fun with that. Nice little bit of probability work there. I will see you again on another video for a little more GCSE maths practice. See you later, Batty fans.